The results reveal that the amount of carbohydrates eaten has a correlation with the distance at which aerobic metabolism begins. Take a look at these graphs. This graph shows the amount of increase in carbs consumed daily. The x-axis is the day of the week. The y-axis is the amount of carbs consumed. This next graph shows that when the intake of carbs increased, the distance at which aerobic metabolism began increased. The x-axis is the day of the week. The y-axis is the distance in miles. The blue line represents the point at which my muscles burned and felt fatigued, and the red line represents the point during the run at which I experienced my second wind, or aerobic metabolism, begins. If you combine the two graphs, you can see that as carb intake increased, so did the distance at which aerobic metabolism begins. So what does this mean? One could assume that when the body has more carbs to burn, it uses those carbs before converting to aerobic metabolism. Now let's not get confused. The body burns carbs during aerobic metabolism as well. The difference is the body uses oxygen to deliver energy to the muscles during aerobic metabolism, as opposed to lactic acid, which is what is used during the period before the body experiences lactic acid muscle burn. That burning sensation in the muscles is the point at which more lactic acid is going into the muscles and less energy is coming out. Remember, the body uses carbs during both types of energy output. So my hypothesis was incorrect. The amount of carbs had little to no effect on the amount of time it takes the body to reach that lactic acid muscle burn and fatigue. It does, however, seem to have an effect on the amount of time it takes the body to begin aerobic exercise, i.e., the point at which the body feels its second wind.